today. Displacement reactions. Okay. So if I talk about here that displacement reaction, okay, the reactions in which the more, note down the definition, the reaction in which the more reactive element displaces the less reactive element from their compound is considered to be as displacement reactions. Okay. In the previous class, we have discussed the exothermic and endothermic reactions.
Yes, sir.
Okay. So note it down.
Okay, sir.
Noted.
Yes, sir, 1 minute. Yes, sir, done.
Now on the basis, okay, that how if I'm saying that what is the criteria that why I'm saying that this is the more reactive element, this is the less reactive element. So note down this reactivity series that potassium is the highest reactive metal. Then after that one is sodium. Then after that one is calcium. Then magnesium. Then aluminium. Then zinc. Then iron. Note it down first. This reactivity series. This is the reactivity series. Okay. Note it down.
Okay, sir.
Done.
Yes, sir.
Okay. So what is displacement reaction? The reaction in which more reactive element displaces the less reactive element from their compound is considered to be as displacement reactions. Okay.
Yes,
So
sir.
what I'm saying here that this one is more reactive, this one is less reactive. On what principle it is made up of? So it is simply we can say here that it is based on the principle that the one which can lose electron first, okay, that is considered to be as the top reactive element, which can lose electron first. It is at the top reactivity. Means potassium can lose electron in a very easy manner, in a very less amount of energy. Okay, so we will say that potassium is the more reactive element. Okay, you understood?
Yes, sir.
So note this one also. Up to 10 you have up to here you have noted. Up to iron or 10. These are the further elements that are below of that
Sir, I
reactivity
wrote
series.
till lead.
till that, right? Right, hydrogen, copper, mercury, silver, gold, platinum. Okay.
Yes, sir. Yes, sir. Done.
Done. Okay. So if I'm going to show you here that when we have a copper sulfate solution, okay, and in that copper sulfate solution, if I add zinc to it, okay, then what is going to happen? The zinc will convert it into zinc sulfate plus copper. Okay, the zinc sulfate solution plus copper will be get converted here. Okay, so the solution will be converted into zinc sulfate. Okay. Similarly, copper when react with iron, it will gives you iron sulfate plus copper. Okay,
Okay,
it
sir.
will give you iron sulfate plus copper. So here the zinc comes above, copper is here. So those metals that are above copper can displace the copper from its compound. For example, if I'm taking iron sulfate, so those metals that are above the iron can displace iron from iron sulfate. Okay. Like for example, if I'm having iron sulfate FeSO4 and I add zinc to it or aluminium to it, so it will gives you aluminium sulfate Al2SO4 whole thrice plus hydrogen plus iron. Okay. So because aluminium is more reactive than iron, so it will displace. Got it? So the more reactive element is displacing the less reactive element. This is known as displacement reactions. Okay. Note it down.
Yes, sir.
Note this one also.
Okay.
Hello, Lisha, how are you?
Good evening, sir. I'm fine.
That I'm going to show you here an experiment in which the copper sulfate solution. Okay. An iron nail is dipped inside a copper sulfate solution. You check it.
One of the most common errors to occur in common entrance chemistry is in describing the reaction between copper sulfate solution and iron, in this case in the form of a nail. If I place a small amount of copper sulfate solution into this beaker and place the iron nail into the solution for a few seconds, a reaction takes place. The nail soon becomes coated with a pinkish brown deposit. When this is mentioned in common entrance questions, the mention of a brown solid in conjunction with iron often leads candidates to think that this brown deposit is rust. However, this is not correct. Iron, being more reactive than copper, displaces the copper from the copper sulfate solution. The brown coating on the nail is copper. If this reaction is left to proceed for several hours, a large amount of copper is displaced from the copper sulfate solution and iron takes its place to form iron sulfate solution, which is the green color that you can see in this beaker.
Now you have checked here that, okay. You have checked here that hey, iron in the iron sulfate solution, sorry, copper in the copper sulfate solution is displaced by this iron nail, which is having the iron particles, iron atoms. So it is displacing and forming the FeSO4, which is greenish color. You have checked the color of the solution. Okay.
Yes,
Is
sir.
that audible? Okay. So why it is doing so? Can you tell me? Why it is doing so?
Sir,
Because
iron
iron is
is more reactive.
more reactive than copper, so it is displacing it. Simple.
Okay.
Okay. So this is
Yes,
the
sir.
iron which is displacing the copper sulfate from its solution and is forming FeSO4 and the Cu. Okay. So we will simply say here that this iron sulfate is formed, which is green in color, and the brown color substance that is deposited over the copper. Oh, sorry, over the iron nail is copper. Okay, brown deposited over iron nail is copper. Iron nail is copper. Brown color substance. Brown
Okay.
substance deposited on iron nail. Okay, deposited on iron nail. On iron nail. On iron nail is copper. Okay, you understood?
Yes, sir.
Okay, and can you tell me that the why the solution, the color of the solution means copper sulfate solution is blue in color? Why it is not brown? Because you know copper solid is brown in color. You have seen the utensils of coppers which are brown in color. So why it is blue in color? Can you tell me? Any idea? Because
Sir,
in
when I
yeah.
think so when copper reacts with iron, the color changes.
Actually, in copper sulfate, copper is present in the form of Cu2 positive. Okay. This is copper ions.
Yes.
This is copper ion, and this copper ion is blue in color. Copper ions is blue in color, and
Blue.
copper solid is brown in color. Means the atom, if the atom of copper, let me explain you here that if the atom of copper is losing its electron, that if it is the atom of copper, it is brown in color. Okay, brown in color.
Yes.
And when it loses its electron, it becomes U2 positive and 2 electrons are losing. So it will be how it is? It is blue in color. Okay, blue in color.
Okay.
You understood?
Yes,
Understood?
sir.
Now again, when this U2 positive receive 2 electrons and become copper solid, then this blue color changes to brown. Okay, and then it get deposited over the iron nail. Okay, that brown color that you have seen there. Okay, got it?
Yeah. Okay. Yes, sir.
So the question comes in examination: why do copper sulfate solution changes to green color when iron nail is dipped into it? So the reason is iron is more reactive than copper, so it will displace the copper from copper sulfate solution and convert it into ferrous sulfate solution. Since the ferrous sulfate has green colors, so the solution changes to green color. Please note it down. Please note it down.
मेरा लगेज कुछ 5 किलो ज्यादा तो 5 किलो ज्यादा लगेज का कुछ था 13,000 रुपए और एयरपोर्ट पे बैग का शॉप था जिसमें
Done? Noted?
No, sir, 1 minute.
You done?
Yes, sir.
Okay, let me show you the just wait a minute. Let me show you the when zinc is reacting with okay uh copper sulfate. Okay. Then zinc will form. Okay. So you can check it here. Copper sulfate and zinc solution. Okay. So this is the copper sulfate solution and it is the zinc strip that is being added here. Okay. Just fasting this reaction. So you will check after some times all the copper ions get deposited over this one, over the zinc metal, and it will become transparent due to the formation of zinc sulfate, because zinc sulfate is transparent. So you can check the solution become transparent just because of the formation of zinc sulfate. Okay, this is the copper sulfate and this one is zinc sulfate. Okay, you understood? Understood?
Yes, sir.
Okay. So here the reactions here is the reaction between the zinc sulfate and the zinc and the copper sulfate. The zinc when react with zinc sulfate, note it down, it become transparent in color. Okay. Similarly, when magnesium react with magnesium sulfate, it will become white in color. White in color, magnesium sulfate. Okay. But if the element that comes below the copper, like silver comes below the copper. These are the element that comes below the copper, like mercury, silver, gold, platinum. Okay. So if these elements like silver, it is reacting with copper, there will be no reaction. Okay. Why? Why? Because silver is less reactive than copper. Okay.
Yes,
Yes,
sir.
You
sir.
are because silver is less reactive than copper, so it will be. So note it down, please. Like why if you are having zinc sulfate and copper is added to it, there will be no reaction. Why? Because zinc comes at the top and copper comes below. Okay. So copper is less reactive. Okay, zinc is more reactive. So it will not be able to displace. Okay. You understood? Understood? Yes or no?
Yes, sir.
Note it down. Note these two equations that will no reactions. When you done, please let me know. I think you got it.
Yes,
Aisha.
sir.
Sir,
Noted, noted. Is there any part that you didn't get in the
no, sir.
displacement reaction?
No, sir.
Okay. Now moving to the next part is that acids when react with metals. Okay. Acids when react with metals, they produce salt plus hydrogen gas. Okay, and it is also a displacement reaction. It is also a displacement reaction. Okay. So you can check it here that acids when react with metals, they produce salt plus hydrogen gas. Okay. So write the names of some acids that are important so that you can know. The name of acids are first is sulfuric acid, H2SO4, then HCl is hydrochloric acid, then CH3COOH. This is COOH. It is ethanoic acid, then HNO3 is nitric acid, then H2CO3 is carbonic acid, then H3PO4 is phosphoric acid. Note it down, please. You done?
Sir, 1 minute. Sir, done.
Okay. Next is if I talk about this acids, okay. Now this, like for example, sodium is reacting with H2SO4. What it will do? It will displace this hydrogen from it and will form sodium sulfate as a salt. Okay. So the formula will be written accordingly. Sodium has a valency 1 and sulfate ion has valency 2. You need to cross multiply and then you have to write it Na2SO4. Okay. Na2SO4. You understood? Understood? Yes or no? So you have to write the formula accordingly. Okay, like for example, if I'm saying magnesium when react with HNO3, it will form magnesium nitrate. So magnesium has valency 2 and nitrate ion has valency 1. You cross multiply, you will get MgNO3 whole twice. Okay, you understood? Yes or no? Mariam
Yes.
and Aisha.
Yes, sir.
Okay, so note all these chemical equations. And then tell me why in this case there will be no reaction. Why in this case there will be no reaction?
Sir, can you explain me once again?
Okay, why not? This is acids. Okay, acids are reacting with sodium. So it will form sodium sulfate plus hydrogen gas. It is the general equation that will form salt plus hydrogen gas. Okay, like magnesium when react with HNO3, it will give you magnesium nitrate. And the formula will be written accordingly. Like sodium has valency 1 and sulfate ion has valency 2. That you have learned from this chart. This chart that, okay, the valency chart. Here is the valency chart. And that there we have learned this all. Okay, sodium has valency 1, sulfate ion has valency 2. Okay, so because of that, the formula for the sodium sulfate will be, tell me, it will be, what will be the formula, tell me, of sodium sulfate? Tell me, it will be Na2SO4. Okay, Mariam, are you doing something? Hello,
No,
Mariam.
sir. Yes, sir.
Okay. So the magnesium nitrate formula will be MgNO3 whole twice. Okay. Like calcium is reacting with HCl, it will gives you
Okay.
magnesium chloride, MgCl2 plus hydrogen gas. Okay. So write down this and can tell me then why this reaction is not going to take place. In case of copper, why it is not able to produce hydrogen gas?
Sir, I wrote.
You also, Aisha?
Yes, sir.
Okay, then tell me why in this case no reaction take place. Why it is not forming copper chloride plus hydrogen gas?
Because copper is less reactive than hydrogen.
Yeah, so it will not displace. Copper is less reactive, so it will not be able to displace. Okay, hydrogen
Yes, sir.
because copper comes below the hydrogens. Okay, so only those metals that are above hydrogen in their reactivity series can react with acid to produce hydrogen gas. So please note this statement. Only those metals that are above hydrogen in the reactivity series are able to produce hydrogen gas on reaction with acid. Done?
Yes, sir.
Yes, sir.
Now tell me the salts. Name the salt that is going to produce here. And what is its formula? Name the salt that is going to produce here.
Sir, what is Mn?
Mn is manganese. Its valency is 4 or 3. So tell me what is going to form here. Okay, I'm just changing the Mn with magnesium. That's valency is 2. Tell me what compound is going to form when zinc is reacting with this one. What is going to form? Tell me fast.
ZnCl2
Yes, it will be ZnCl2 plus.
and hydrogen gas H2.
Okay, here. Tell me, in this case, what compound is going to form?
Sir, I don't understand. Can you explain me?
Yes, zinc will displace this hydrogen and will form chlorine, and zinc are going to form the compound. So it will be zinc is valency 2, chloride ion valency is 1. So that why it will be ZnCl. Okay. In this case, this hydrogen will be removed. So what is the formula will that is going to form here? That will be magnesium and nitrate ion. MgNO.
MgNO3 whole twice and H2.
So if you cross multiply, you will get MgNO3 whole twice. This will be MgNO3 whole twice. Okay, plus hydrogen gas. And this one, Mg magnesium sulfate. Magnesium has valency 2 and sulfate ion has valency 2. So both are same, so it will be MgSO4. Cancel out each other. Okay. You understood?
Yes, sir.
Now here, displacement and double displacement reactions. Okay. So the reaction in which there is simultaneously exchange of ions take place is called double displacement reactions. Okay. The reaction in which there is simultaneously exchange of ions takes place is called double displacement. We are just studying the double displacement reactions.
Sir, what do you mean by exchange of ions?
Exchange means, I'm going to explain you. Simultaneously means there is not one after the other. It is simultaneously. Means both are exchanged. For example, this barium is with chloride ion, and here in this one is sodium with sulfate ion. But they are exchanging. Barium will come with sodium sulfate ion, it will form barium sulfate. And this sodium will come with chloride ion, it will form sodium chloride. Okay.
Yes, sir.
Okay. So they are exchanging their ions. So both are exposed. But here the barium sulfate precipitate is white precipitate. So when this reactions, when the solution of barium chloride and sodium sulfate are mixed together, then they will form barium sulfate, which is white in color. It's precipitated white, is white. Okay. Note this reaction.
Sir, can you scroll up?
Yeah, just done, noted.
No, sir, 1 minute.
You noted, Aisha.
Yes, sir.
So let me show you that how this reaction is going to take place. Okay. So here is the barium sulfate salt, barium chloride. Okay. And it is water soluble and it form clear solution. Barium chloride form clear solution. Okay, you can check it. Now we have sodium sulfate, Na2SO4, and we are dissolving it. We check it here. Okay, as soon as he added few drops of sodium sulfate to it, the color of the solution changes. Why? Because it is barium sulfate is formed. Is it visible to you?
Yes, sir.
Sure. So it's become white in color. Okay. Let me show you the another one. That is lead nitrate and okay. Let me show you the another one. The lead nitrate and potassium iodide. Okay. So both reactions, lead nitrate and potassium iodide, if you check it. Okay. So one is potassium iodide, another one is lead nitrate. And here they are, you can check it. This beaker is going to have the lead nitrate. This is lead nitrate. And this one is going to have potassium iodide. Okay. They both are mixed together, mixed separately in separate test tubes in water. Okay. And their solution is being prepared.
Of potassium iodide. Now this is PbNO3 powder, lead nitrate. I am going to add water in it. Shake it well. Now PbNO3 whole twice is, this is the aqueous solution, this is the aqueous solution of potassium iodide. Now all potassium compounds are soluble in water and all nitrates are soluble in water. Now you can add any.
Can you guess the color of the solution that when the test tubes are mixed? Can you guess the color?
Sir,
Maria?
yellow.
Oh, you have written.
Yellow.
Sir, it's there on the top.
solution into one
Yeah.
another. There you go, people.
Yellow.
Fantastic. So here, as you can see, that the precipitates have formed and the precipitates are yellow in color. Now let's find out from the reaction that which is this yellow precipitate over here.
Is of potassium, sorry, lead iodide.
So
Lead iodide. Okay.
Yes, sir.
Yes.
we know that all compounds of potassium are soluble in water. So that means KNO3 dissolves in the water. So we have water in it and KNO3 is already dissolved. So that does not dissolve in.
Okay, so the substance that here you can check that the aqueous part, the liquid part is of potassium iodide, sorry, potassium nitrate, and this yellow colored particles are of lead nitrate, okay, which are not soluble in it. Okay, so the precipitate is going to form here, and that is PbNO3 when react with potassium iodide, it will gives you PbI2 and KNO3. So have you noted this equation? Tell me yes or no.
Yes, sir.
Yes or no. Similarly, this ferrous sulfate when react with NaOH, it will gives you ferric hydroxide, which forms brown PPT, and sodium sulfate.
Sir, how do we know which color it will form?
Actually, there are 4 to 5 reactions in your syllabus, and from that you have to memorize. Okay,
Okay, sir.
so do this one. Since in this type of reaction, okay, precipitate means some insoluble substances form. That's why it is also called precipitation reaction. Okay,
Yes, sir.
it is also called precipitation reaction. Done?
Yes, sir.
Yes, sir.
Okay, write down the next equations also. That what is the color of ferrous hydroxide? What is the color of ferrous hydroxide? What is the color of this one? What kind of precipitate is going to form? Tell me. Tell me fast. It is brown. Why are you not answering? It is brown PPT. Okay.
Okay, sir.
Okay, sir.
Now, silver nitrate when react with NaCl. Next reaction, next displacement reaction. Silver nitrate when react with NaCl, it is going to form NaNO3 plus AgCl. And the element that is less reactive, it is going to form PPT. Like for example, sodium and silver, which is less reactive. Silver is less reactive, so it will form PPT. Okay. And the color of silver nitrate, silver chloride is white.
White.
Okay, sir.
So note it down. Silver nitrate is transparent. This one is transparent. When they mix together, they form silver chloride, which has white PPT. It has white PPT. Done?
Yes, sir.
Yes, sir.
Okay. Next. Another type of reaction between that you are going to study when in the acid base and salts. When acids react with bases, okay, when acids are going to react with bases, this is also a type of displacement reaction. Okay. So in simple, we will simply say that if AB react with CD, it will gives you AD plus CB. This type of reaction is going to form. Okay. You understood? Understood?
Yes, sir.
So the reaction between acid plus base will gives you salt and water. It is also a double displacement reaction. It is neutralization, and double displacement, as well as exothermic reaction. Thermic reactions. Okay. For example, if you
Sir,
are
can
having
you tell me the definition of neutralization?
that acids and base reactions, acids are opposite to the base. So when you add acid with base, they become neutral. Okay. That is called neutralization reaction.
Okay.
So acid, for example, acid is HCl. It is reacting with NaCl, NaOH. It is a base that you will going to study in the acid base reaction. Sorry, acid base and salt chapter. So here this Na and Cl will combine together to form NaCl. The formula will be written accordingly. That Na has one valency, Cl has one valency, so it will form NaCl. Plus H and OH will combine. So H and OH is actually water. HOH is water. So we write it like H2. Okay. Understood? Like for example, if you are having H2SO4 when react with NaOH, so this time the formula will be Na and this sulfate ion is going to form. So it will be sodium sulfate and formula will be written accordingly because Na has valency 1 and sulfate ion has valency 2. So the cross multiply, you will get Na2SO4 plus hydrogen gas plus water. Okay. Got it?
Yes, sir.
Got it. Next is HCl when react with tell me what it's going to form when HCl react with magnesium hydroxide. What is going to form?
H2O and NaCl.
MgCl2. It is Mg na. It will be MgCl2 plus H2
Okay, sir.
because magnesium has valency 2 and chloride has valency 1. So cross multiply, you will get MgCl2. Okay. But in this type of reactions, no precipitate is formed. Okay. And this is an acid base reaction. So we'll say that it is a neutralization reaction. Okay. But in the above one, you can check here. This is the precipitation reaction. So it is known as, it is also double displacement, but precipitation also. Okay. So we can say that displacement reactions are also two types. Displacement reaction are of two types. Sorry, double displacement reactions are of two types. One is neutralization. And the second one is what is the second one? First is neutralization, and the second one is precipitation. You understood what is precipitation? In which some insoluble substance is found. Okay.
Yes, sir.
Okay. So that's all for today. We'll meet you in the next class. Okay. I hope you enjoy the class. Okay. So neutralization is acid base
Okay, sir.
and precipitation is formation of some insoluble substance. Formation of some insoluble substance. Okay. Okay. You
Yes,
understood?
sir. Yes, sir.
Note it down and then you can leave.
Okay. Okay, thank you, sir.
Oh, bye-bye. Take care, everybody.